In this lesson, called the cosine law, we're going to give you the very last tool we're going to work on for solving triangles. The first tool was called the sine law. Well, I guess previous tools, you could use SOHCAHTOA, our regular trig ratios, or the Pythagorean theorem. Then we went on to the sine law, and now we're doing finally the cosine law. So this is here because there are certain situations in which the sine law will not work. You don't have the right type of information to solve for any missing pieces. If you remember, in the sine law, we depended on a completed side angle pair. Okay, so let's look at this triangle over here. So side A is over here, angle A is over here. And we depended on having one of those side angle pairs completely filled out in order to use the sine law, right? Because the sine law is A over sine A is equal to B over sine B. And you can also use that for C over sine C. But if you don't have a completed side angle pair, then you can't solve for any missing pieces. Doesn't work. So there are going to be sometimes certain sets of information that you're given in a triangle that you don't have a completed side angle pair. There's no way to fill it in. And so then you cannot use the sine law. And instead, you will use the cosine law. So there are certain situations where only the cosine law will work, and we're going to try to show you exactly which situations those are. Before we get there, I'm going to point out what it is. So this is the cosine law right over here. It's just beautiful, isn't it? A squared equals B squared plus C squared minus 2BC times the cosine of A. Yeah, there's a lot in there. I can see part of it is the Pythagorean theorem though, right? A squared equals B squared plus C squared, where normally we would say C squared equals B squared plus A squared. But you can see that happening at the bottom over here. That would be the same thing. But this last bit, this minus 2BC times the cosine of A, or whichever version you're using, that allows us to use it for every triangle, not just right-angled triangles. The Pythagorean theorem only works for right-angled triangles. So we need to expand that a little bit. So really, I would recommend, if it were me, I would use just one version of the cosine law. Notice that we've given you 3 versions of it depending on which letters you're using. I would use just one version of it and rename the letters in my triangle accordingly. Okay, so personally, I would use this last one over here. C squared equals A squared plus B squared minus 2AB cosine C, but you can use whichever version you want. The important thing is, and I want you to notice this, that the C over here, side C, matches with the angle that you're putting in over here, cosine C. Same thing over here. This side B matches with this angle B, and this side A matches with this angle A. The other things are always the same. B squared and C squared go in these spots, and B and C go in these 2 spots over here. Okay, and that's all that's left, right? If you put an A in the front and an angle A in the cosine spot, then it's just B and C that go in the other 2 spots. So hopefully, after you've reused this a few times, you'll get used to how it works and what it looks like. So usually we're going to first of all look, can I find a side angle pair? Can I use the sine law to solve this problem? But if you cannot, if there is no side angle pair, then we move on to the cosine law. So as an example, take a look at this guy over here, this triangle on the right. We are given angle B, 45 degrees, but we are not given side B. So that is not a completed pair. We are given side A, but we are not given angle A. So that's not a completed pair. We are given side C, but we are not given angle C. And so that is not a completed pair either. So there is no way to use the sine law in this particular triangle. but with this triangle we can use the cosine law. So this top one is an example just like the one you just saw, where you're given one angle and two sides. So this triangle is called PDF, but that's not really necessary to call it that. We can call it CAB if we wanted to. It makes no difference what you call the corners. So we can write it down in the PDF way, but I'm also going to write it in the CAB way. Okay, I'm going to do both of those things. So if we are looking for a side length here, that's this side. This would be side P, right? Because this is angle P over here, and so the side across from that is side P. And so we would set up our cosine law like this. P squared, we're looking for side P, is equal to the other two sides, which are D and F, so D squared plus F squared minus 2 times D times F times the cosine of, and then we go back to P. Okay, that would be this version of the cosine law. Okay, but I can also just change the letters if I really wanted to. If you always want to work in A, B, and C, I'm fine with that. I don't know, you can talk to your teacher about if they're fine with that. So we can also write it like this. I'm looking for side C. Now let me just change colors here so that we're not confused about the letters. So this would be side C, this would be side A, and this would be side B. Okay, it's always across from the corners. Now we would be doing C squared, that's the side we're looking for, is equal to A squared plus B squared minus 2AB times the cosine of C. That's the renamed version. And then we're just going to put in all the numbers that we know. So we don't know C, so we're going to leave it C squared. We know A is 16. We know B is 11. Minus 2 times 16 times 11, because that's A and B, times the cosine of 70 degrees. Now, if we've got it set up like this, all of this stuff on this side of the equation, you can just punch that all into your calculator, all in a straight line, exactly like it says, and it will work out just fine. But we should recognize that when we do that, we are actually getting C squared. We are not getting side C. And so then, to get rid of that squared part, we need to square root it, right? And so we'll end up doing C is equal to the square root of whatever that is. And that's 256.61 if you put it all together. And so we want to do the square root of that, which gets us 16.02. Now, we don't have any units on any of this stuff, so we don't know if it's centimeters or meters or millimeters or whatnot. But it's important that you arrange the equation properly. And if you've arranged the equation properly with the side you're looking for out here and the angle that you have over here, and they have to match, right? They have to be across from each other. Then plugging in the rest of the stuff is very simple. There's no algebra that's required or anything. If you are looking for an angle, if you're looking for angle C over here, then that's when some algebra will be required. So I'm going to show you how that works, but you can also just either memorize or write down what the rearranged version is for angles. So here we go. We are given 3 sides, and we are looking for angle B. So if we're looking for angle B, we want to make sure that angle B is in that cosine spot. And in order to make that happen, we need to start out with side B on the left side of the equation. So B squared equals A squared plus C squared minus 2AC times the cosine of angle B. I know that this is right because angle B is the thing that I'm looking for. Okay, so I can rearrange this equation now to get B by itself. So here's how it works. I'm going to subtract A squared because I want to get, I'm trying to get this thing. I'm trying to get this angle B by itself, so I have to get rid of all the other stuff that's on the right side of the equation. So I want to subtract A squared because it's a positive A squared right now. I want to subtract C squared because it's a positive C squared. I need to divide by negative 2AC, right? Because these two things, they are multiplied together right now. And so to separate them, I need to do the opposite of multiplying. And so I'm going to divide. But this is a negative 2AC, so I need to make sure that I'm dividing by negative 2AC. Okay, so I end up dividing by negative 2AC, and that gets me cosine B by itself. So here's what it looks like when I've put it all together. Cosine B is equal to B squared minus A squared, because that's one of the things that I was doing right there, minus C squared, that's the other thing right there, and I need to take all of that and divide it by negative 2AC. Now there are other versions of this formula that make this a positive and these two things positive. So let me write down an alternate version and then you can choose which one you want to use. So you could also do cosine of B is equal to negative B squared plus A squared plus C squared divided by positive 2AC. That works as well. Some people like that version better because it has way more positive signs in it versus all the negative signs in the original one. It does not matter which one you use, you will get the same answer. So we're going to put in the numbers now. Cosine of angle B is equal to, and I need to make sure now that I put the right numbers in the right spots. So this is side B because it's across from angle B. This is side C. This is side A. If I do not put them in the right spot, I will not get the right answer. You can't just put them in willy-nilly. So this is 33.6 squared minus 37 squared, 37 squared minus 43 squared, and I can see that that's going to be a negative number when I do all that stuff. So it's a good thing that I'm dividing by negative 2 times 37 times 43. When I do all that stuff, I get 0.656 lots of decimal places. So the cosine of angle B is 0.656. Okay, that doesn't tell me what angle B is. That would be a really, really small angle. And I can tell by looking at angle B over here that it's not 0.656 degrees. So I'm forgetting that last step. Well, I'm not forgetting it. Maybe you're forgetting it. So cosine B is 0.656. I need to do the inverse cosine in order to figure out angle B. So angle B is equal to the inverse cosine of 0.656. And when you do that, you get 48.97 degrees. And that's actually what angle B is. So to sum up, we've got two versions of the cosine law. One is arranged for finding a missing side, and one is arranged for finding a missing angle. And so we've got kind of three versions of it. You can name the corners however you want to, but I'm again going to point out what's important. So we can start with a squared equals b squared plus c squared minus 2bc times the cosine of a. That's the first version for looking for a missing side. So if your missing side is side A, then your cosine of your angle should be angle A. Okay, that's important. The other pieces to this equation are just the other two sides, b and c, b and c. If you rearrange this to be starting with a different letter, we would do the same thing. So we would go, let's say, c squared equals a squared plus b squared. So the other two sides, minus 2 times a times b, still the other two sides, times the cosine of c. And then we see that the angle and the side match each other. They're a pair. They're across from each other. So you can put whatever letters you want in there, and it's going to work that way. Now the version that's built for angles. So the rearrangement that we ended up with in the previous example was the cosine of some angle, angle A, is equal to a squared minus b squared minus c squared divided by negative 2bc. Now I personally like this version because the angle that you're looking for is right here, and the side that you start with is the matching side. So I find that nice, but the trade-off is that you have a negative in the bottom over here, and some people really don't like that. Okay, so there's another version of this that you can use, and it goes like this. Cosine of angle A is equal to b squared plus c squared minus a squared divided by 2bc. And in that case, the angle that you're looking for is right over there. The side you're looking for, or the side that matches, is right over there, and it's the only negative thing in the whole equation. Okay, both of these equations work exactly the same. So whichever one you like better is fine with me. You just need to choose one that makes the most sense to you.